Iran can shut the Strait of Hormuz for roughly 72 hours. After that, the blockade begins failing, not because of firepower, but because of logistics. The strait is only 21 miles wide at its narrowest point. On a map, it looks like leverage, a thin corridor through which nearly a fifth of the world's traded oil passes. It looks decisive. It looks like a switch, but choke points create compression, and compression creates strain. Closing a strait is not the same as controlling it. Control requires persistent patrol coverage, missile batteries ready to fire, minefields deployed and monitored, radar networks operating without interruption, air defense interceptors loaded, fuel nodes active, reload systems moving, crews rotating, and command links functioning without pause. Not for an hour, not for a headline, continuously. And the moment that operation begins, degradation begins. The first 6 hours are shock. Fast attack craft surge outward. Coastal anti-ship missile batteries power up. Mines enter shipping lanes. Commercial traffic halts. Oil futures spike. Insurance premiums surge. The world watches satellite images and red arrows on maps. Shock works because it is immediate and visible. But shock is not sustainment. Sustainment is repetition under pressure. By hour 12, fuel consumption becomes the first invisible constraint. Small boats operating at combat throttle burn reserves quickly. Engines pushed hard in hot salt water accumulate wear. Cooling systems strain. Radar arrays run continuously, generating heat stress across electronics. Missile units reposition and demand resupply. Every maneuver consumes something: fuel, inventory, maintenance margin, crew endurance. By hour 24, rotation cycles tighten. Boats require refueling. Crews compress rest windows. Reload vehicles move between hardened storage sites and dispersed firing positions. Maintenance teams abandon preventative schedules and begin triage repairs. Spare parts inventories begin to matter. The blockade is now a system under load, and systems under load reveal weak points. The strait itself is narrow. The battle space around it is not. US surveillance does not need to enter the choke point. Satellites monitor emissions. Maritime patrol aircraft map movement patterns. Drones loiter beyond missile arcs. Submarines track surface vessels and support ships from standoff distance. A blockade requires visible presence inside confined waters. Counterpressure does not. That is the asymmetry. Iran must operate continuously in a predictable environment. The United States can apply pressure from multiple domains without compressing itself into the strait. Sustaining a blockade forces exposure of the machinery behind it. Fuel distribution nodes, missile reload cycles, mine reseeding routes, maintenance hubs, communications relays, interceptor magazines. The longer the blockade continues, the more visible this machinery becomes. Start with mines. Mines create uncertainty faster than missiles. They do not need to sink ships. They only need to create hesitation. But mines do not permanently close a strait. They force clearance, and clearance is a throughput contest. Mine countermeasure operations are slow but relentless. Helicopter-towed sleds sweep lanes. Dedicated mine hunters scan grids. Remotely operated vehicles identify and neutralize contacts. Each cleared lane restores limited commercial flow. The blockade becomes a race. Can Iran reseed mines faster than lanes are cleared? Reseeding requires boats or submarines to depart port, transit predictable corridors, deploy mines, and return to reload. The first reseed benefits from surprise. The second reseed benefits from confusion. The third reseed establishes pattern. Patterns are trackable. Trackable routes become targetable routes. Now consider missile batteries. Missiles enforce the blockade. They punish escorts and threaten clearance operations. In the first 24 hours, concealment works. But every launch produces a signature: heat plume, radar spike, communications burst. Firing reveals position. Missile warfare is governed by reload tempo. Truck-mounted anti-ship systems require reload cycles. Crews move multi-ton canisters under heat, fatigue, and surveillance. Reloading takes time. Time reduces firing frequency. Relocation reduces targeting risk. But relocation reduces rate of fire. Fixed positions maximize output, but fixed positions become predictable once identified. A blockade is not a single volley. It is repeated cycles: detect, fire, reload, relocate, resupply. Each cycle consumes inventory. Each cycle increases exposure. Inventory is finite. Exposure compounds. Now add fast attack craft. Swarm tactics create early disorientation, but sustained operations force repetition. Repetition creates pattern. Fast boats must refuel, they must rearm, they must rotate crews. Engines pushed hard in confined waters degrade quickly. Maintenance intervals compress, spare parts availability becomes decisive. Fatigue accumulates in small crews operating at high tempo in extreme heat. A minor breakdown in peacetime is an inconvenience. In a blockade, it is a gap. Gaps reduce coverage. Reduced coverage creates vulnerability windows. By hour 36, exposure density increases. Reload vehicles follow repeat routes. Radar emissions are mapped. Patrol craft cluster near refueling points. Support vessels sustaining small craft become high-value targets. Iran's doctrine excels at short, sharp denial inside confined waters. But a blockade is sustained friction. Fuel for boats, reloads for missiles, replacement parts, cooling systems for electronics, interceptor depth for air defense batteries, crew stamina, command stability. Every layer must function simultaneously. Every layer adds a node. Nodes can be degraded. By hour 48, the system begins paying interest on tempo. Fuel inventories shrink. Missile magazines thin. Maintenance backlogs grow. Crew fatigue accumulates. Radar operators extend shifts. Decision cycles slow. Air defense commanders begin calculating remaining interceptors rather than optimal firing solutions. The posture shifts from dominance to endurance. Meanwhile, counterpressure expands. Carrier strike groups operate beyond confined waters. Air wings cycle sorties without entering predictable missile envelopes. Submarines track logistics vessels and patrol craft. Long-range ISR fuses targeting data continuously. The United States does not need to clear the entire strait at once. It needs corridors. Escorted corridors restart commercial flow. Once escorted traffic resumes, total denial becomes partial disruption. Disruption is weaker than closure. Iran can create disruption. Sustained coercion requires duration. By hour 60, degradation accelerates. Refueling traffic increases detection probability. Detection increases targeting probability. Missile reload cycles become constrained by magazine depth. Resupply movements become predictable. Predictable movements become vulnerable. Mine reseeding demands repeated exposure. Repeated exposure increases attrition risk. Every sustainment action creates another vulnerability window. Vulnerability compounds. Second-order effects follow. Convoys consolidate. Escorts refine tactics. Commercial shipping adapts to cleared lanes. Energy markets stabilize once corridor flow resumes. Strategic leverage depends on duration. A 3-day disruption produces volatility. A 3-week closure produces coercion. That is the difference between spectacle and sustained power. Iran can generate spectacle. Sustaining power requires structural depth. By hour 72, the blockade becomes a test of throughput. Can fuel cycles continue uninterrupted? Can missile inventories remain replenished? Can radar networks persist under electronic and kinetic pressure? Can patrol craft avoid clustering around vulnerable hubs? Can mine reseeding outpace clearance? Can maintenance backlogs be absorbed? Can crews maintain performance under fatigue? If any one layer falters, the blockade transitions from dominance to disruption, and disruption fades. Maritime denial is not measured in headlines. It is measured in endurance curves. 72 hours approximates the convergence point where fuel rotation strain, magazine depletion, maintenance backlog, crew fatigue, exposure density, and ISR precision intersect. Before that threshold, shock masks fragility. After it, logistics exposes fragility. Logistics imposes arithmetic. Sustained control requires depth. Depth of fuel reserves, depth of missile stockpiles, depth of maintenance capacity, depth of interceptor magazines, depth of trained personnel operating continuously, depth of redundancy across nodes. Without that depth, operations compress inward. Iran would not collapse at 72 hours, but it would transition from projecting dominance to managing depletion. Once an operation shifts into depletion management, tempo transfers. Tempo determines initiative. The United States does not need to eliminate every platform. It needs to stretch the sustainment layer, stretch fuel cycles, stretch reload intervals, stretch maintenance windows, stretch radar endurance, stretch interceptor depth, until the system can no longer absorb strain. Eventually, something gives. Not explosively, structurally. The strait appears narrow on a map. Sustaining a blockade within it is logistically expansive, and that expanse is finite. 72 hours is not a guess. It is a system's threshold. Thresholds determine whether power projection holds or fails under the weight of its own logistics.